Hello, we will learn patterns and sequence today. What is a pattern? Pattern is a rule that we can apply to predict what happens next. Just like this example, you see 1 here, 2 here, 3 here, so you know the next one will be 4. What is a sequence? Sequence is a list of numbers that follow a pattern. The two very famous and important sequences we have to learn in our math class are arithmetic sequence and the geometric sequence. Arithmetic sequence looks like this. You have a common difference between consecutive terms. In geometric sequence, you will have a common ratio between consecutive terms. In our class, we will concentrate on arithmetic sequence only for right now. You will learn geometric sequence in Algebra 2 and Pre-Cal. Here we are going to learn more detail about the arithmetic sequence. We have to learn some terminology first. First one, this D is for common difference. A sub 1 is the value for first term. Some people use a function denotation f of 1. That means the value at position 1. A sub n is the nth term. Some people write it as f of n. It means the value at position n. We call these numbers terms. Using this example, we can see D equal to 3. A sub 1 is our first term, is negative 5. Our second term is the first term plus 3. That is negative 2. Then the nth term is the n minus 1th term plus 3. In other words, nth term is its previous term plus 3. That's our sequence. Here is another way to express this relation. A sub n equal to negative 5 plus n minus 1 times 3 equals to 3n minus 8. We call this kind of form explicit form, and this one is recursive form. We will talk more about recursive and explicit in the next slides. Basically, recursive is using a rule or procedure that can be applied repeatedly. Explicit means you can get the value at nth position directly using n. These two formulas are same thing. Basically, it tells you how to find any nth term. This is explicit way. The nth term equals to the first term plus n minus 1d. What does that mean? You can use this example. We already know our first term is negative 5. And to go to next term, we have to add 3. Every time we want to go to next term, we just add 3 to the current term. So how do we find the fifth term? Fifth term, n equal to 5. So we just use negative 5, that's the first term, plus 1, 2, 3, 4. 4 of the 3. We will get 7. That's what this formula means. So if you want to find the nth term, you use the first one plus n minus 1 times each gap Each gap is the common difference. Here we have more example about the recursive rule and the explicit rule. Recursive rule, the value of the nth term is obtained after we know the value of the n-1th term. Like this example, if we want to find a sub 5, we cannot find that directly. We have to start from a sub 1, then we get a sub 2 from a sub 1, then we get a sub 3 from a sub 2. That's how we find our sequence. If it's function denotation, you do the same way. You just have to say f of 1 is your first term and f of 2 is your second term, and that second term equals to the first term, subtract 4. Because this given example, your common difference is negative 4. This is the explicit rule. A sub n equal to negative 4 times n plus 7. So if we want to find the fifth term, you just plug in n equal to 5 to the formula directly. So a sub 5 is negative 4 times 5 plus 7 is negative 13. We have to mention for recursive rule, n has to be greater or equal than 2, because when n equal to 1, that means the first term, and the first term is always given. For explicit rule, you can start n equal to 1. That means just plug in 1 into your formula to get your first term. So we make n greater or equal than 1. Here is an anchor chart to show how to develop explicit rule from recursive rule. Recursive rule is what we can see from our sequence directly, because you see the relation between two consecutive terms immediately. A sub 1 is given whatever value you have, so we just put another a sub 1 here, means they are same thing. A sub n is a sub n minus 1 plus d. That just means nth term is his previous term plus a common difference. Now we just write every term out. A sub 1 is whatever initial value they give you. A sub 2 is a sub 1 plus a d. A sub 3 is a sub 2 plus a d. Keep going until you see a sub n equal to a sub n minus 1 plus a d. Now we can add all these equations together. Then the left side and the right side, we see all this same term like a sub 1, a sub 1. They cancel each other. A sub 2 on the left side, a sub 2 on the right side, so we can cancel them together. So they all get cancelled until at the end, we see only a sub n on the left side, and the right side, we have the initial value a sub 1 here, plus all these d's. There are n minus 1 of those d's. So this is our formula, a sub n equal to a sub 1 plus n minus 1 d. In this formula, you can see we know a sub 1, we know d, n is our variable. So our value at nth term depends on the position n directly. That is why this is called explicit rule. Using this example, 3, 8, 13, 18, you can see d equals to 5, that's the common difference. And a sub 1, the first term is 3. So we apply the value for first term and d to our formula. A sub n equals to a1 plus n minus 1 times d. Our d equals to 5. You apply distributive law and combine like terms to simplify this expression. At the end, you get a sub n equal to -2 plus 5n, or you can write it the opposite way, equals to 5n minus 2. This becomes our explicit form. This is another example just for you to see the difference between recursive rule and the explicit rule. You have a sequence 3, 7, 11, 15. First term is 3. The common difference d is 4. So recursive rule is written as first term equal to 3, then nth term is the previous term plus 4. If you want to find the fifth term, how do? You have to do it one by one. You find a sub 1 equal to 3, that is given, then a sub 2 equals to first term plus 4. The third term equals to the second term plus 4. You just keep going until you find the fifth term. But if you are given the explicit rule directly, then you can apply n equal to 5 directly to the formula. Then you will find that value at the position 5, which is 19. Most tests we are given for sequence problems are in two different types. First type, you will be given the sequence and ask you to find the rule, like this one. And the second type, you will be given the rule and asked to generate the sequence. This first type, you are given multiple choices for different rules. Of course, all these rules are explicit rules. You're trying to match which rule can get you this sequence. And this one, the rule is given, and you can see this rule given is a recursive rule. You know the first term, then basically it's telling you any term you want, that is the previous term minus 4. This is how we solve this problem. For the first type, if you know the sequence and trying to find the rule that fits this sequence, you can use plug-in method. Just plug in different n into each of this rule to check. Like this one, you plug in n equal to 1 to all these 4 answers. You found they all equal to 5. That means they all give you first term 5. So now try n equal to 2. That means trying to find the second term. So put 2 into all these rules. You find only the last one will give you 8. 8 is the second term for your sequence. So your answer is D. But if you're not given all these multiple choices to choose from, then you can develop your rule just using the formula. A sub 1 is 5, that's your first term is given, and you see the common difference D equals to 3. So plug in A sub 1 and D into your formula, then clean it up, simplify. You will get the answer a sub n equal to 3n plus 2. That's how you find your answer. If you're given the rule, how to generate the sequence, because the rule you are given is a recursive one, so you have to find your terms one by one. First term, f of 1 is 3, that is given here. Then the second term, f of 2, is the first term minus 4. That's what your rule says. So first term, the value is 3. 3 minus 4, you get negative 1. Then the next one is this second term, subtract 4 again. So negative 1 subtract 4, you get negative 5. And so on. So you get your answer 3, negative 1, negative 5, negative 9. That's how you find your sequence. That completes our lesson. Thank you.